Um, Hello everyone. In this video, I'll explain about the Verilog code for D flip flop. Um, in my right side, this the design part of the code of D flip flop, and the left hand side, this is the test bench code where we test that design part code, which gives correct output or not what we give the input. Okay. Um, what is a D flip flop? Whatever we give the input for the D flip flop, that D flip flop gives the output as same what we give the input. Okay. Um, D flip flop is a sequential circuit. That's why we use the clock, and this is the module declaration, line 1, and end of the module ending, and in that module name d underscore ff, and in that we declaring the inputs and outputs whatever the we give for the circuit that, and I mentioned as an input clock and d input clock and d in, and for the inputs, and the outputs is output range equal to q, and the output qb. Okay. Yeah. And for every pause edge clock, pause to edge trick, pause to for every pause edge. Okay. For every pause edge means for every pause edge, that input q equal to d. Okay. This is an declaration about the always begin, and this is a non-blocking statement, and this is a blocking statement, where we using that in the always block and all in the for the non-blocking statements, and assign q equal to q bar, q bar equal to in negation of q. Okay. And end of the module. Okay. Yeah. This is an overall design part code. Okay. And we'll go to the next test bench code, uh, module declaration, and starting module declaration and then module, and we'll give a separate name for the test bench, and whatever the we declared as inputs for the ridge and wire in design part, that will be reverse for that inputs and outputs of the ridge and wire whatever we declared in input, that as well as declared in that test bench. We can change also, but okay, we can change also, but uh, we are using the uh, positional augment. That's why we don't change those inputs. That's why, and we use the positional augment, and design part module name, and with the separate name of the separate name. These are the positional augment. What are the inputs we declared in the design part that actually declared in test bench, and initial. Uh, I'll explain it later. This part. Okay. Yeah. Initial begin clock equal to 0, and forever every clock 3 uh, clock equal to negative of clock. End of this initial. Okay. This initial begin. Initial begin, in the initial begin we are giving that inputs of d equal to 0, d equal to 1, d equal to 0, d equal to 1, and put and the finish. For every initial begin, uh, this will be walk for this initial begin, and this initial begin for every d equal to 0. Okay. D for every input, and for every clock, that for every 5 seconds this will be executed. Okay. These will be added. Okay. And finally, after these execution statement, this will be completely finished program. Okay. For that, for this dollar finish statement. This is a overall test bench, overall code of D flip-flop we're using. Just we run this code. Come on, come on. Yeah, 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 yeah. These are the inputs. Just check it out. Okay. Thank you. Thank you for watching this video.